Hello, welcome for today's session. Today we are going to discuss about current and voltage divider rule, part 6. This is VTU Model question paper, CBCS scheme. They asked in 2015-16. The question is, calculate the power delivered to 16 ohm in a circuit below. Shown below for 5 marks. This is the circuit. Our aim is we have to find the power delivered in 16 ohm resistor. So the given data is total voltage is 200 volt, and then power we have to find the power in 16 ohms. In the above circuit, 4 ohms, 16 ohms, and 4 ohms are connected in series. So to find the total resistance for these three resistors, 4 plus 16 plus 4 will get 24 ohms. So now the circuit is reduced like this. See here. Now the circuit is reduced like this. This element, this 3 here, before it was 3 resistors was connected, that is 4, 16 and 4. Now it is reduced into 24. So this 24 and 24 both are connected in parallel. See here, this 24, this I can redraw like this. 24 ohms and 24 ohm resistors are connected in parallel. Already we discussed that parallel circuit, if it is having the same resistor, we know the shortcut how to do that. In the above reduced circuit, 24 ohms and 24 ohms are connected in parallel. So 24 is the value of resistor and divided by number of resistance. So 24 by 2 will get 12 ohms. Now again the circuit is reduced. See here, 6 ohms, 12 ohms and 6 ohms. All three are connected in series. So 6 plus 12 plus 6 will get 24 ohms. Again it is reduced to 24 ohms resistor. Now the circuit we can redraw like this. See here. See in this. Again the circuit is reduced like this. 200 volt is given in the source voltage, and then 8 ohms, 24 ohms, 8 ohms. This 24 is just we reduced as a resistor. Again this 24 and 24 are connected in parallel. So here we know how to simplify the parallel circuit. So 24 divided by 2 will get 12 ohms. Further the circuit is reduced like 8 ohms, 12 ohms and 8 ohms. All three are connected in series. So 8 plus 12 plus 8 will get 28 ohm. Therefore the total resistor R total is 28 ohm resistor. So already we know that according to Ohm's law, I is equal to V by R. I is equal to V by R. So I total is equal to V total by R total. So 200 divided by 28. 200 is the total voltage given in the question. R total, just now we found the total resistance. So the total current is 7.14 ampere. This is our answer for total current. Now the total current is going to divide in all branch. This is the entering current, that is the total current I am naming as I, and then here the two branch current I1 and I2 I just name. According to using the current divider rule, I1 is equal to total current into opposite resistance divided by total resistance. So using this formula we can easily find I1 value, that is 3.57 ampere, and then I2 value 3.57 ampere. Current is dividing equally because there are two resistors are connected in parallel. They are having the equal resistance. Now coming for the main diagram, that is from the main circuit diagram, this is our total current that is going to divide into two equal value, that is 3.57 and 3.57. Again whenever it is coming to this junction, it is dividing as a I1 dash and then I2 dash. So this, if you add this is the total resistance is 24. In this, if you add that 16 plus 4, 20, 20 plus 4 is 24. Again we are having the same resistor. So the current is going to divide equally again. So I1 dash is equal to total current is I2 and then opposite resistance, that is I2 dash divided by I1 dash plus I2 dash. If you substitute the value, we'll get I1 dash will get 1.785 ampere. Similarly, if you do for I2 dash, we will get 1.785 ampere. Now the question is, we are supposed to find the power delivered in 16 ohm resistor. So P is equal to I square R. That formula we know in general. So power in 16 ohm resistor, the current flow is in the 16 ohm resistor is 1.78 ampere. So 1.78 square into 16 will get 50.69 watt. Now problem number 2. This question also they asked in VTU model question 2015 under the current and voltage divider rule. So calculate the supply voltage. Calculate supply voltage V in the circuit shown below. This is a given circuit. We are supposed to find the voltage in voltage V, that is the total voltage. Here all the values are given. If any two, see here, we know that current, resistance and voltage. According to Ohm's law, V is equal to IR. If any two values known, we can easily find the unknown values. But here all the values are given as a resistor, but here only one clue is given, that is here they given as a 10 volt. 10 volt is across the 5 ohms and then 10 ohms, because this 5 ohms and 10 ohms are connected in parallel. Whenever it is a parallel circuit, the voltage will remain constant. So now just I am concentrating only this part, this parallel two elements. So this voltage 10 voltages will be same for 5 ohms as well as the 10 ohms. So we know that according to Ohm's law, I is equal to V by R. So I1 is equal to V by R1. V is common for I1 as well as I2. So for 10 by 5 will get 2 ohms. So in the I1 the current which is flowing is 2 ampere, and then I2 will be, that is V value is 10, and then I2 here it is 10 ohms resistor is there. So 10 by 10 will get 1 ampere. So I2 is equal to 1 ampere. I1 is 2 ampere. I2 is 1 ampere. So the total current is I1 plus I2 will get 3 amperes of current. Now in this part the 3 amps of current is flowing, that is the total current, and then it is dividing, whenever it is coming to this branch it is dividing into 2 branch current, 1 amps and then 2 amps. So already we are aware of that here the voltage is given as a 10 volt. So in this part, but in the given question, see here 5 and 10 are connected in series. So if I add this I'll get 15 ohms. That's what I given in this diagram. So this it becomes 15 ohms. So in this part V is equal to IR. So I value is 3 amps and then R value is 15 ohms. So we'll get 45 watt. So from here to here we are getting 10 volt. From here to here we are getting the 45. So totally is 10 plus 45 we are getting 55 volt. So the 55 volt is in this total circuit. So the 55 will be present in this branch also. So coming to next step, see this 55 volt is present in this branch also. So whenever here the resistor and then voltage is known value, so we can easily find the current value. So I in 10 ohm resistor, that is the current in 10 ohm resistor is 55 divided by 10, we are getting 5.55 ampere. So current which is flowing in this branch is 5.55 ampere and this branch is 3 amps. So already we know that according to Kirchhoff's current law, I is equal to I1 plus I2. Similarly I1, I am considering this is I1, so it is 5.55 plus 3 amp, we will get 8.5 ampere. So this current is 8.5 ampere. So our aim is we are supposed to find the voltage. So voltage means already we know that this voltage is 55 and this voltage we don't know. So if you here the R is given and then I is given, so V is equal to IR. So if you multiply V is equal to I into R, we will get 85 volt. So the total voltage in the for the circuit is this value and this value. So it is 85 plus 55, we will get 140 volt. That is the answer for this problem. I hope you enjoy this session and subscribe this video. Thank you for your support.